Hello, so in this video I'm going to discuss section 2.4 from the book, okay, which is the chain rule. So far we saw the power rule, we saw the derivative of the sum and difference of a function, we saw the product rule, right, we saw the quotient rule, we saw so many rules, okay. But they are able to do so many problems involving the derivative of a function. But there are some more functions that we don't know how to find out the derivative, okay? Let us take an example. So if y equals to x plus 1 whole squared, that is square, how do you find out y prime? Okay, for this one, it was not a bad problem because you can write this as, let's say y equals to, you just FOIL it, right? You can do x plus 1 times x plus 1. So before you find out the derivative, you just simplify it. So if you FOIL this, x times x is x squared plus x times 1 is x plus 1 times x is x plus 1 times 1 is 1. So you get x squared plus 2x plus 1. That's what you get, right? Now, when you find out the derivative, you write y prime equals to, find out the derivative of x squared is how much? 2x, right? And then what is the derivative of 2x is plus 2 times derivative of x is 1, right? Because I'm using this formula. And then plus the derivative of 1 is 0. So your final answer is basically 2x plus 2. That is the derivative. Now, you see what formula did we use here? We used derivative of x to the n with respect to x. That's how we call, right? The derivative of x to the n with respect to x. Meaning that if you match this base x, that x, with that x, but the numerator x has some exponent, then you write the exponent times x to the exponent minus 1. Okay? If both of them matches, xx or tt or yy, uu, like that, if they match, then you can use that formula. If they do not match, you cannot use that formula. For example, on this case, look at this case, x plus 1 squared. If you want to find out, let me write slightly different way, okay? Suppose you are writing this derivative as d over dx plus 1 to the square over dx. Look at this. You cannot use that formula directly. Why can't you use that formula directly? Because look at this. That has, it is like x to the n. You can think that way, but that x is x plus 1, right? There is x plus 1 on the base. There is just x in the base. If they don't match, you cannot write like 2 and then x plus 1 times 2 minus 1. You cannot write that way. That's not how it works. You need to have the same just x and just x there. Or just u and just u. Just you need to have the same variable here and here to use that formula. Okay, so I was able to use that because this the derivative of x squared is basically dx squared over dx, and you could write 2x 2 minus 1, and then you're writing 2x, right? Similarly for this one, you're writing 2 and then dx over dx, right? You can write dx to the 1 and then 1x 1 minus 1, or you can cancel that and say, you can think that way, okay? You can think the cancelling of those, and then you can say just 1. So 2 times 1 plus the derivative of 1 is 0. So you can think that way. But this problem was not very bad because you were able to FOIL it, okay? And then write that form. But if I take y equals to root x plus 1, then how do I find out y prime? Because I cannot FOIL it, right? You cannot write like, you can write this as x plus 1 to the 1 half. That is what the root means. But I don't know how to do after that, what to do after this, right? So if I want to find out the derivative, do you know that this derivative can be written as dy over dx is same as y prime? These are just the different notation, but the same thing, right? If you want to find out the derivative of this, then how would you write that is dy over dx. I'm finding with respect to x because x is the only variable here. And then you write d over dx, x plus 1 to the 1 half, right? Now look at this. You cannot use just simply the power rule here. Why? Why can't you use the power rule? Because there is x plus 1, right? There is x plus 1 in the base. There is just x in the base. So they don't match. So you cannot use the power rule. So how do I do this type of problem? So the method or the rule or the formula to do this type of problem that has exponent and then cannot be simplified is called the chain rule. Okay, it is called the chain rule. So it is very, very easy. Don't panic. Okay, so how do I do this type of problem is I will do this way. Okay, I will write let u equals to x plus 1. I will write this as x plus 1. Then how can you write that then? Then I will be able to write this as, I'll be able to write like dy over dx as I will be able to write du to the 1/2 over dx. Now it looks better, but still a problem because we didn't do anything new. I just denoted that base, not with the exponent, just the base as u to the 1/2. Okay. Now I want to use the power rule. My goal is to use the power rule because there is power, right? But I cannot use power rule 8. Why? Because there is u. You see that? There is x. They do not match. But how can I make them match is I will do like this. Du to the 1/2 over du times du over dx. You see that? You can think of like cancelling du and du, right? But what you get is ultimately you get du to the 1/2 over dx, right? If you cancel them out. But you don't want to cancel because you want to use the power rule for this. Because see, now they match, right? There is u to the 1/2 divided by u. Now they match. You see that? Now, look at this. So what is the derivative of that? You use the power rule. 1/2 u 1/2 minus 1 times. What is the derivative of u? Look at this. Derivative of u with respect to x. Okay? You will find out the derivative of x and 1 separately. Derivative of x is 1. Derivative of 1 is 0. So that is just 1 plus 0. Okay, now how can you write that? So it is 1/2 u to the negative 1/2. You see that? Because 1/2 minus 1, this is 1 plus 0 is just 1, and then you multiply with 1, it stays the same, right? Now how do you do that? You move that to the denominator because I don't like the negative exponent to keep negative exponent. So I want to move that 1 over 2 u to the 1/2. Okay, now you can write this as 1 over 2 root u. But here is the problem. Your question was in terms of x. Your answer must be in terms of x. So you need to replace that u back. So the final answer here is 1 over 2 root under x plus 1. That is the derivative of this function. Okay.